Good morning and welcome to the GELION PLC investor presentation. Throughout this recorded presentation, investors will be in listen-only mode. Questions are encouraged and can be submitted at any time by the Q&A tab situated on the right-hand corner of your screen. Simply type in your question and press send. The company may not be in a position to answer every question it receives during the meeting itself. However, review all questions submitted today and publish responses where it's appropriate to do so. Before we begin, we'd like to submit the following poll. I'd now like to hand you over to John Wood, CEO. Good morning, sir.
Good morning, and thank you all for coming to this presentation today for GELION. It's been a remarkable period of time in the last few months, and we thought this would be an opportune time both to thank the people who participated in our recent round and to update you on the strategy for the company and the progress that we are making. I'd like to start by introducing my panelists with me today. We're fortunate to have our founder, the remarkable Professor Thomas Maschmeyer, with us. It's almost exactly a year now since I've been in the company, and originally I was attracted to GELION by the opportunity to work with Thomas. I've not been disappointed. The man is a genius, and it's a lot of fun working with Thomas and the team that have assembled around him. And I feel very fortunate to have had this chance. Stuart Rayner, my partner in commercializing our activities. We work very hard together, and it's a great pleasure to work with Stuart. And Amit, the tireless Amit, our CFO, diligent and energetic. So each of us will take you through our progress today. All right. GELION, a battery technology innovation company, and we are working on two technologies. We're working on a lithium sulfur technology, and we're working on a zinc-based hybrid technology. Now, these are two very important technologies. Lithium sulfur, and particularly the sulfur and the zinc, are two of the most abundant battery chemicals around on the planet. We see lithium sulfur as extending the lithium battery industry, being the next stage of lithium industry, and that's a huge industry. It's an industry that will be at 1.3 terawatt hours by 2030. Now, there's another great industry as well. That's the lead acid industry, and the lead acid industry is a little different than lithium. Lithium is a sort of clean room, high technology industry. The lead acid industry is a robust industry, very strong, robust batteries. And that's where we see our zinc-based technologies playing. So we see zinc as being a natural extension of that great ecosystem, which is the lead acid ecosystem. Another way of saying that is GELION is a battery technology company that wants it all. We want to be the next stage of lithium, and we want to be the next stage of lead acid. And we're going to talk to you today about how we're going to achieve that. All right, we particularly are drawn to talk to you following our recent raise and acquisition. And we're very pleased with that acquisition. That was the acquisition of Oxford. Now, earlier this year, we updated you that building on the early stage breakthroughs that GELION had in lithium sulfur, particularly in additives and electrolytes associated with lithium sulfur, that we had acquired from Johnson Matthey an extensive portfolio of IP around lithium sulfur. That IP has proven to be, even better than we thought, and so we're very happy with what we got from that. Well, that development was done by a group in the UK. Originally, that IP was developed by Oxis. And we're very pleased with this acquisition that we're reuniting some of the brain power that was associated with Oxis. What happened there was that after Johnson Matthey had picked up the Oxis technology and IP, the UK government had carried things forward, supported development of batteries in the UK with an initiative called the Faraday Institution. Faraday Institution had about £500 million, if I have it correct, which they've been putting into keeping the UK at the forefront of advanced technologies. And inside that, there was a group called LiveStar that was particularly investing in lithium sulfur. young man, Adrian Amiguez, who had worked for Oxus and been in charge of IP for Oxus, he took on a role and started a company called Oxlid. While the UK government was supporting the development of lithium sulfur inside the academic institutions in the UK, Adrian was building a small team, and he put a few licenses in place with some of the universities that were doing that work and continued that work forward. We're very fortunate that we were able to reach a meeting of the minds with Adrian and his team and to get them to join Team GELION. So there's a little picture it's a very small picture there of Adrian up in the top left. And right alongside him is a gentleman, Gareth. He's leading technologist. And by some twist of fate, Gareth had actually spent some time with our own Professor Thomas Maschmeyer earlier in his career. So we knew the quality of the people that we were working with and that we were managed to secure to our journey. So we picked up some very important people and capability in the UK. We picked up a few more patent applications in some important positions, some facilities, and the ability to make some samples up in the UK and at Fraunhofer in Germany. We picked up some commercial relationships, including with one with Sanyo Trading as well, and importantly, the relationship with Faraday. And I do draw attention that the Faraday institution does have on its website at the moment a timeline that shows you the history and the pedigree of all of this IP and the work that we're doing here. Very importantly for GELION, as shareholders, what this does is move us forward very fast, jumps us forward on our TRLs, and enables us to move forward with our goal towards major strategic relationships. Okay, so, well, yeah, we were going to talk to you about Oxlid alone, but we happened to pull another major transaction, which was this relationship and JDA with Ironblocks that we just announced in the last few days. This is all towards establishing true global presence and leadership for GELION. So Oxlid brings a lot to us. Firstly, we've been working on our lithium sulfur cathode technology, and Oxlid brings some very special capabilities in that moves our TRL forward, our technical readiness level, sorry to use the terminology there, forward quickly. They also bring access to some advanced lithium metal anode technology, particularly some important IP that have been licensed by the company. We will be working with Oxlid across all of our activities. The team is now part of Team GELION, and so they're across all of our activities, but particularly in the UK, we're going to be continuing to work on that those lithium metal activities. We are super excited to be able to complement that acquisition with this JDA with Sujit and his team at Ironblocks. So this is a really formative and very, very important relationship that has formed here. So GELION has been working towards attaining leadership in lithium sulfur technologies. And one of the pieces of work that our team had been in breakthrough mode on was how to complement a sulfur cathode with multiple anode technologies. That was secured, or our protection in that area was extended through the Johnson Matthey IP acquisition. And one of the important anodes that we can connect to is called an SiOX, or a silicon oxide anode. Now, that's where Ironblocks excel. They have SiOX technology. I think that you could almost call these guys dominant in the pre-lithiated SiOX area. Why is that important? Well, it's in an area that again leaps us forward, because this is an anode technology that when we complement it with sulfur, gets us way past some of the things that have held us back or held others back on lithium metal approaches. Simply, it's a faster path, we anticipate, to being able to make whole cells where those cells have stable performance and high performance, low cost and high safety. So we're absolutely thrilled to have this opportunity to work with Ironblocks, a major company and a great partnership. And Stuart and Thomas will talk a little bit more about that as we proceed with our presentation. Get Amit to take you through the transaction.
Thank you, John. So in terms of the transaction, the Oxlid transaction, what did we acquire? We acquired 100% of Oxlade, which is a UK-based lithium sulfur company, and we valued the deal at £4.2 million. We made sure the structure of the deal is such in a way where the risk and rewards are equally shared between the founder and ourselves. So we paid 1.25 million in cash on completion. Completion is tomorrow, so the payment will be made tomorrow. 400,000 pounds is deferred and paid in cash over 6, 12, and 18 months. This is to ensure the founder is works with the business and is subject to certain performance hurdles as well. 2.5 million in shares in GELION PLC, and this is escrowed for 18 months. So again, making sure the risk and rewards are equally distributed, everyone works together to make GELION a success. We funded the acquisition through the existing cash resources that GELION had, and also using some of the non-EIS funding that we raised in this round. We acquired the entire IP portfolio, as John mentioned, and we complete the transaction tomorrow. The rationale for the transaction: why did we acquire Oxlade? Obviously, it gives us a presence in the UK, which is quite a big market for lithium sulfur. There's a lot of research organizations and research activities happening in the UK, like Faraday and Lifestyle program, which John spoke about. It gives us access to potential customers in Europe as well. On top of all of these macro commercial considerations, Oxlade also has approved grant funding from the Faraday and APC program. So post-acquisition, we'll have circa £700,000 of grant funding, which is approved but undrawn. So we pay 1.25 million tomorrow, but we'll get £700,000 in grants back. Obviously, John spoke about the team, the intellectual property, and strategic fit. We can accelerate our LIS sampling. They also have a very good relationship with Sanyo Trading, and they generated some revenue in FY22. While there is no confirmation of that revenue continuing, we want to explore the relationship further post-acquisition as well. So that's something very interesting for us. And I think this cannot come at a better time for GELION, because the UK government just announced the UK battery strategy yesterday. So multi-billion-dollar going into the battery strategy. And with presence in the UK, we are definitely in the right spot to get government help there as well. John, back to you.
Okay. So looking at the position of your company, GELION. Today, the mature industries are lithium-ion and lead acid. You're seeing some incursion into the market from sodium-ion, but very solidly, the next generation technologies are lithium-sulfur, zinc-based or multivalent-based, and solid-state. Now, when we look at what we're doing in lithium-sulfur, the IP portfolio that we picked up from Johnson Matthey comprised IP from right across the spectrum of liquid electrolyte systems through quasi-solid state systems through solid state systems. And so your company, GELION, is solidly positioned in all of these major battery technologies that we're looking going forward. How do we commercialize them, which is really the most important question? Well, first, we achieve leadership, then we commercialize. And our intention in the case of both of our technologies is to follow the fastest path to commercialization using a capital light approach. So when you look at these tables in front of you, you can see the progress that has been made by the remarkable team that we have inside of GELION in the period since the IPO, and particularly with a lot of momentum starting to build in the last 12 months. So we advised earlier this year about the acquisition of the IP that had been developed at Sydney University. We quickly moved into accelerating through expanding our lithium sulfur capabilities in Sydney. And now we've just done the Oxlade acquisition and the Iron Blocks JDA. Well, you can see now that this next one, which is starting to provide electrode samples to our partners, well, we're going to be exchanging electrode materials with Iron Blocks straight away. So we're off to a bit of a head start on our goals looking forward. We're doing our safety testing, and one of our big goals and the primary KPI that we've set for ourselves, or myself, next year is that we're looking to form some major strategic partnerships. We're not going to slow down. GELION is on a mission to get this technology out into the global landscape. There's a mention of an advanced commercial prototype facility, and there's a couple of great countries to be involved in batteries right at the moment. One of them is Australia, and one of them is the UK. And I guess the US is not too far behind that at the moment. But there's a lot of government incentive out there. And so our plan is to be putting in place a capability, and from that capability to be able to provide samples out to our partners around the world, or partners that we want to develop around the world. You then see the company progressing through the demonstration pouches and then in the validation cells to our partners. On the zinc side, there's been a magnificent job done by our team this year. I really have to hand it to the group that is working inside of GELION. So we had our Gen 4 cells. We produced our Gen 4 cells. We learnt quite a lot from those Gen 4 cells, and we realized that when we had those cells, that we wanted to do more. We needed to do more in order to meet the combination of safety, cost, and performance all in one cell that we see as being the sort of compelling proposition to really get behind and start to scale commercially. So a team knuckled in and got after it, and have been doing a great job. So using those Gen 4 cells, first of all, some remarkable progress was made on the anode. So we wanted to make this product fit the market, and we realized that stripping the cell, taking it down to zero, wasn't going to be convenient for our customers. So we wanted to go beyond that, and very proud of the team for the work that they did to overcome that challenge. We then went into the cathode, and Thomas, again, pulled it off for me because he introduced me to the remarkable Professor Yuan Chen, who's one of the world's leading scientists in the particular area that we wanted to move faster on. We put a relationship in place with the professor at Sydney University. We've been moving forward very quickly on that. So all that work is coming together, and at the end of the first quarter next year is an important milestone that I've set to update shareholders on the progress of our zinc performance. This stage, everything is going along pretty well, and the team's making great progress on each front. Of what we anticipate getting to at that point in time, we then start to move forward into our Gen 5 prototype. I mentioned that we want to work on a capital light approach, and to that extent, we have started working relationships already. Now, the lead acid industry is one where we have a lot of great manufacturers around the world, but a small number of process equipment manufacturers. And so one way for GELION to accelerate will be to work closely with the infrastructure suppliers that work within that industry today. We've started to talk to them already, preemptive to our technology team bringing the technology along. That brings us to Gen 5. So our Gen 5 is, product on the zinc side is something we have high aspirations for in stationary energy storage. And you can see then going forward, we'll be doing our manufacturing process equipment, our pre-pilot production plants, and then moving forward to scaling up. So you have a disciplined commercialization and realization program going on inside your company, and you have a team that is working remarkably hard to achieve those goals, and creatively and effectively. Let Stuart tell you about our lithium sulfur technology.
Great. Thanks, John. Good morning, everyone. The next few slides will really be talking to you about why we're passionate about lithium sulfur technology as the next generation of battery tech to really support the transition to renewables. We'll cover off the key applications, the advantages, some of the tech challenges that need to be solved, and how GELION is approaching this market to obtain the leadership position for lithium sulfur technology globally. Now, if we think about key applications, the whole globe's heading towards zero net emissions. And if you look at the EV market in particular, last year there were 10 million EVs sold, and the projection are that 300 million will be sold by 2030. Now, in order to make that happen, we need breakthrough battery technology like lithium sulfur that has got lower costs, it's much safer, better energy density to support that transition and really make it happen, to drive up the amount of EVs that need to get out there to reduce emissions. One of the other key applications that we're focusing on is aviation. So if you think about the aviation industry, if the aviation sector was a country, it would be the 7th largest emitter in the world. So pretty significant. So it's very good for us to get about trying to electrify aviation as well and reduce those emissions. If you think about all the flights that are done around the world, greater than 50% of those flights are less than 500 miles. So that's within the distance that the energy density of lithium sulfur and the power rating can achieve. So we can electrify aviation also. Now, in terms of the key advantages of lithium sulfur compared to existing lithium ion technologies, what GELION's about, we're about bringing a better battery to the market, a greener battery, lower cost, safer, with higher energy density. So let's look at the energy density side of things advantage. The gravimetric energy density is double what current lithium ion technology can deliver. So what that translates to is double the distance that your cars can travel. So a reduction in range anxiety between the amount of distance you can travel between charges of the car. One of the other also benefits of our technology is it's a much lighter battery. So if you put a lighter battery into an EV, then the EV manufacturers, they can actually put in lower spec brakes and suspension systems because it's not carrying around as much weight. That helps to drive down the overall cost of EVs as well. When you think about the bill of materials, we're estimating a 45% reduction in the cost of these batteries. So if you compare that to lithium NMC, nickel, manganese, cobalt, one of the leading technologies that's out in the market today, all of those metals, we want to replace those metals, which can be high cost and have various supply chain pressures that people have seen over the last couple of years. We replace that with sulfur. And what sulfur is the fifth most abundant element on planet Earth. So from a supply chain perspective, it's a fantastic element to be working with for next generation battery tech. Where do we get the sulfur from? In addition to the fact that it's very abundant, we're actually able to get the sulfur from the oil industry. So at the moment, oil industry, when they get the oil out of the ground, it goes through a desulfurization process, and they have an incredible amount of waste sulfur that we're able to take, wrap it into the cathode of our batteries and produce these greener, safer, lower cost batteries. And because we're not mining the elements there on the cathode, so we're forming a metal-free cathode, we can basically provide a much more sustainable battery out to the market by reducing the carbon life cycle between 30 to 60%. So that's fantastic from a sustainability point of view, and when we need to be producing millions of these cells in the future. And the other key thing is improved safety. So too often do we see EVs with fires or explosions, or stationary energy storage systems with fires that burn for 6 or 7 days. Forget about that when it comes to sulfur. Sulfur handles high temperature much better than the current technologies. So we can say goodbye to fire and explosion. So you've got a much safer battery. So that enables more people to want to buy EVs and fly in electric aviation. Now, the key challenges. So I've talked to you about the advantages of lithium sulfur, and they're very well known in the industry and very well accepted. The technology challenges that the industry has been attempting to solve over the last period are two key challenges. And this is what GELION is putting all of our effort into solving. And Thomas will tell you a bit more about our approach, which is helping us to get into that leadership position on a global basis for lithium sulfur. So the key two problems, first one is a lower life cycle. So what happens, you can see there in the center of that slide, that's a high level picture of a cell, battery cell. The cathode there is sulfur. The anode on the far left is lithium metal. And what's happening there in the red, polysulfide shuttle, that paradigm basically corrupts the battery and only enables the battery to last for about 50 to 100 cycles. So what happens is polysulfides, they move from the sulfur cathode, are absorbed into the electrolyte and shift across to the anode, and then they corrupt the anode, enabling it to only last 50 to 100 cycles, which isn't long enough to have a full commercial battery. So that's technology issue number one that we're getting about solving. The other one is the power rating. So sulfur has the benefits we've discussed, energy density, cost, safety, but its power is a little lower than traditional lithium ion. So we need to do some pretty special technology effort into getting that power to the right level for EVs and electric aviation. Now, in terms of how we're getting about this, John mentioned earlier, and you would have seen in our press releases over this last 12 months, we firstly acquired the Johnson Matthey and Oxis IP. Oxis spent about £100 million, 10 years, developing their lithium sulfur technology to a global best position. And we've now acquired that. We competed against 20 other companies to get our hands on this IP. And we're combining that with the work that Thomas's team have been doing in Australia. And combining that with the Oxlid people that we've just acquired in terms of the company to put together the best approach to lithium sulfur in the market. We've got a very broad patent portfolio, 65 patent families, which translates to, I think, around 400 patents, covering the full range of battery development. And the other extra bonus in that patent portfolio acquisition was about 10 to 12 patents based on battery recycling. And this is a extra bonus, I guess, for our business and our shareholders, because we've had numerous companies approaching us wanting to commercialize that recycling IP with GELION. I'll hand to Thomas, who will take you through the next slides.
Great. So what is it that's special about our approach? So we have a sulfur cathode platform technology, and it is different to just about everybody else out there. It's one can go with a approach which is similar to what is in your battery in the iPhone, where we have a lot of electrolyte inside the battery. The problem with electrolyte, which is the liquid that effectively connects the anode and the cathode and makes the system work, that electrolyte is dead space. It's not able to store energy as such. So the more electrolyte, the lower the energy density. So that is one way in which some companies are designing their lithium sulfur batteries. We don't do that. Another way is to go the other extreme and say, well, I will have no liquid whatsoever, and I need to have these electrodes and the electrolyte, which will be solid one, touch very, very well. That is not easy to do. If you think about two pieces of paper and you try to put them together at the atomic level, and even higher than that, you can imagine there will be gaps. And whenever there's a gap and an ion has to pass through that space, there is resistance. And wherever there is resistance to movement, and the energy used up by the battery to overcome that resistance means the battery is less efficient. So our approach lies in between those two extremes in our first sort of manifestation of our lithium sulfur technology. And that is what we call the quasi solid state. So in a sense, we can conceptualize it as putting just a smidgen, a tiny little bit of highly specialized liquid between those two sheets of paper or between those two sheets of plastic, and they then connect very, very well. And that allows us to suppress the polysulfide shuttle, because that liquid is unable to dissolve the polysulfide, so they can't move across. But we still have great conductivity, ionic conductivity, great connectivity, and that is effectively where our patent space is. And if anybody wants to go, not to the extremes of full liquid electrolyte or solid state electrolyte, but something in between, we are there. That's our space. And the academic literature, I think, is starting to also show that that is the path to success. If you have a look at the different kind of patent areas we're covering, obviously we're covering the anode and the cathode. That's what you do early on, of course, to make sure your battery technology actually works. And as one gets further developed, so of course we need electrolytes to have the anode and the cathode talk to each other. And then we need to be able to design batteries and be able to manufacture them, so design for manufacturing as well, and manage the batteries as cells and as packs. And as you can see, we are covering all of those areas, and those areas are indicating an increasing level of technology readiness. So with our platform sulfur cathode, we can tune the battery. We can make different types of batteries. We can make power batteries. We can make really high energy density batteries, or ones which have significantly longer life cycle, but still very high energy density, higher than anything that's out there at the moment. So it's a real platform, and we can tune it to the applications that we need. So we have a multi-anode capability, and that means that, some of you may remember the VHS and Betamax discussion, who was going to win. VHS finally did in videotapes. With lithium anodes, it's a little bit the same. Is it going to be lithium silicon? Is it going to be lithium metal? Is it going to be lithium silicon oxide? We have views of how this is going to go, but there are lots of companies out there trying to make it happen. We can pair to any of those, and our strategy is to look at partners to pair with. So we are very flexible in that our IP sits in our cathode formulation that is tuned to go along with these anodes, and we then have tuned electrolytes, very important, that are able to allow our sulfur cathode to talk to the different anodes. So it's an electrolyte sulfur cathode package that is then used to pair with those anodes. So it's very exciting, and it covers high energy and longer life cycles. And the formulation itself is reliant on having some catalytic materials in there as well. Sulfur is a bit sluggish, but our laboratory at Sydney University, our group, and also the people we are now working with at Oxlade are very experienced in catalysis and have a great track record in catalysis, and we're very confident to be able to accelerate some of those reactions, and then the battery becomes more and more of a power battery. It enables this catalytic materials enable the energy to be released quickly and also to be taken up quickly. So that is a lot of the work that's going on at Sydney University. If I compare what I just talked about, the lithium metal sulfur combination and the lithium silicon sulfur combination, the gravimetric energy density, so the weight for the amount of energy in the battery, is more than 2 times that what it is in your iPhone right now. And if you look at Chinese electric vehicles, which are using lithium iron phosphate batteries, which are lower in energy density, we are significantly more than twice, maybe 3 times as energy dense if we look at lithium metal sulfur combinations. The penalty is cycle life is a bit less than for LFP, but they're still comparable to the batteries that you have in your iPhone. These cycle lives are on a cell level. On the system level, that can be managed to be to be many more cycles. In terms of safety, we also, of course, are safer than lithium NMC or lithium NCA, the batteries that you see blow up all the time. Sulfur, if something goes wrong, extinguishes the battery. Given that we are in the lithium metal sulfur battery using lithium metal, we don't get the full marks, but there are ways of handling passivation of lithium metal as well to make it safe. And we do have an exclusive license to that from the University of Oxford. Material supplies, we are, of course, fantastic. Sulfur is a waste of the petrochemical industry, and there's a huge amount already there at battery grade purity, because it is made from hydrodesulfurization in the refineries, taking out sulfur from gas and sulfur from crude oil. Then the most recent development, as John was saying, we have now a joint development agreement with Ionblox, who are the world leaders in lithium silicon anodes, and we can pair with those. And we still get a very good gravimetric energy density there, first up, but a much, much longer cycle life and incredible safety as well. And potentially we can come up with packs which combine these two technologies as well, the lithium metal and the lithium silicon, to give very, very long range batteries for cars, etc. So, as I was already saying, our 2 approaches are to partner with Ionblox for the lithium silicon oxide anode. And well, we were partnering, but then we liked them so much, we bought them. I think that's the guy with the Remington said the same. He liked the company so much he bought them. So they're now part of the family, and we're going together forward to accelerate our path to market. Oxlade not only supplies great technology for the formulation of the sulfur cathode, but also is making great progress in connecting that to a lithium metal anode. And Iron Blocks, of course, is the leader in lithium silicon oxide anodes. So overall, we are pretty excited about our path, our optionality, and our partners, and the quality of our partners.
Okay, looking forward to the commercialization. So we're building the great technology. Now we want to go to market. When the technology is going to market, we want to use a capital light approach and to work within the existing supply chains. And so to that extent, we see that our best path forward is to, first of all, implement what we call our Advanced Commercial Prototyping Center. And that facility is the interface between us and the large manufacturers of the lithium batteries and the large customers for the lithium batteries. So that Advanced Commercialization Prototyping Center becomes, really central to our commercialization efforts. And now we go to pilot scale. And at pilot scale, we see ourselves maintaining leadership in performance. So we want to surf the edge of performance and maintain the edge of performance. But then as we scale beyond, we want to be part of the existing global community and the global supply chain. And to that end, the most logical approach that we see is to be commercializing high-value materials. And so our intent is to implement our materials, utilizing our IP and our technologies, and then to work with partners who can facilitate the provision of those materials into the global supply chains and into the gigafactories. To the very biggest customers, we will also entail licensing of our technologies. So leading edge cells, high value materials, and ultimately licensing of our technologies to maximize the return on our leadership and our technology work for our shareholders. Turning to the zinc technology.
Thanks, John. So switching gears, zinc is very much focused on the stationary energy storage market. The key applications that we're targeting to begin with will be lead acid replacement applications. So the lead acid market is $45 billion per annum US, and we'll be focusing on providing stationary energy storage solutions for remote power supply, off-grid for miners, telco tower battery systems, and also for data centers, uninterruptible power supply batteries for data centers. Data centers going through another massive growth phase at the advent of AI, so a whole heap more information being stored, so they're needing many more batteries to keep their environments in place. Zinc's a great battery for that. And then we'll be moving more toward the traditional solar farm, wind farm, scaling up of battery tech for those applications. One of the awesome things about zinc technology from GELION is it can operate at very high temperature ranges without requiring air conditioning systems. So air conditioning systems end up becoming a very, very large OPEX over the sort of the 5 to 10 year lifespan of batteries. So if you can remove that, it really helps the competitive advantage of our zinc batteries. So why do we love zinc? For a battery input, zinc's very, very cheap. So it's a low cost input into the battery. And if you're competing against lead acid, which have been around for 130 years and at low cost, you need to make sure that you can compete on that price perspective as well from a CapEx point of view, and then have an OPEX advantage also. It's very, very sustainable and scalable. Last year, we proved that we could make 1,200 cells, zinc-related cells in lead acid format. And that means that when it comes time for us to scale up our zinc batteries, we'll be able to partner with global lead acid batteries, and our batteries will be able to be made in their ecosystem. So that's a real advantage for GELION on our zinc tech. And it's also very, very safe and water-based technology. Thomas.
Yeah, so of course you've heard me talk a lot about zinc bromide, and we've made 3,000 zinc bromide cells and have about 1,000 or so of them being used around our various programs. And Acciona currently is underway, and the cells are performing very, very well. And we've learned a lot about how to make these cells, how to manufacture, etc. But you will remember when John came in as CEO, as an expert in lead-acid batteries and the whole ecosystem, he felt that it wasn't the right time for us to go into megawatt-hour production at that moment, and pulled it back and said, really what we need to be able to do is get away from having to strip. So everything else was working quite well, but to strip was still something that needed to be done well. And the reason for that is that we need to have cells that can cycle at partial states of charge without growing dendrites. So we put a pause on the on going to the megawatt hours, and developed the anode further, and that was very quick progress, such that we are able to now switch the battery chemistry, because we are much better at plating the zinc than we were before. Now that allows us to be more flexible on the cathode side, so on the bromine side. So bromine is a great battery chemical, but is also somewhat problematic in terms of manufacturing, etc. One needs to have some pieces of equipment which can handle the material constraints around bromine. Lots of other reasons. At the end of the day, what we've been able to do is switch the cathode into a material which is much more benign and still delivers the performance of the zinc bromide and a little bit more. So if we go to the next, slide, we have the zinc bromide, which is our generation 4. As you can see, under these various parameters, it is outperforming largely lead acid, as we've always said. But then the zinc generation 5 is even better. And we are looking at much better cycle life, much better behavior around irregular charging and discharging, and so and a higher energy density as well. We're keeping that robustness in terms of operating temperature. We're actually improving it still, and so at the end of the day, it's a cheaper and better performing zinc battery. So we've learned a lot, and we're taking about 2/3 or so of the designs across from the zinc bromide and put that into this battery approach.
Thank you, Thomas. So I'll quickly summarize the financials for FY23. Just as a reminder, FY22 is audited, FY23 is unaudited results, but we are pretty much done with the audit, so the numbers are not going to change. Pretty pleased to report that on all the three measures, total income, adjusted EBITDA loss, as well as the cash position, the actual performance is much better than what was expected. And these expectations were set at the time of IPO. I think everyone is aware how the world has changed since the IPO. You talk about continuing COVID impact, Ukraine war, inflation, interest rate rises, employee retention and everything. But we have come out on the right side. So very, very pleased with the efforts. So on a total income, it was approximately 20% higher than what we anticipated, whilst ensuring EBITDA loss is lower as well. The cash is largely as expected, but this is after the £3 million that we spent on the Johnson Matthey IP acquisition. This wasn't part of the plan when we did the IPO. So if we didn't acquire the Johnson Matthey IP, we would have been around £10 million, which is significantly higher than expectations. So the underlying message here is the team at GELION is taking really good care of the cash that we raised at the time of IPO, and we are making sure the cash is deployed in the most efficient manner and used for the right purposes. The result that I just summarized wasn't a fluke. Since John has arrived, before John, there was a big focus on cost, but since John has arrived, we have actively reduced cost across the business and across all categories, being staff, contractors, marketing, and other. And the estimated savings is around £1 million on an annualized basis. So this is a fantastic result, and this just shows how much we value shareholders' funds. Thank you, John. Back to you.
Okay, so what I'd like to do is summarize for you all. Our goal is to, first of all, establish leadership for our technologies. That's essential. batteries are a global industry. To be successful in batteries, you must establish leadership. Secondly, having established leadership, we want to move fast by integrating into the global supply chain using capital light approaches, as I've explained. So we're going to attain that in lithium sulfur by leveraging the IP that we've acquired and the great start that we've been given by our own team, integrating the OXLiD acquisition, working with the alliance we've put in place with iron blocks into lithium silicon sulfur, continuing our development towards safe lithium metal sulfur, and then moving quickly towards the high performance cells, the high value materials, and to licensing. On the zinc side, we're going to keep moving our progress forward with the work that we've done and the progress we've made on our anode, the work that we're doing in partnership with Professor Yuan Chen on the cathode at Sydney University, and then again moving as fast as we can to commercial integration into the supply chain, working with the supply chain participants around the world today. Looking at this in a summary diagram form, what we've done on the zinc side of our business is to target in such a way as we can move to a lower cost of production, a higher performance cell, something that meets the match to market, even while increasing the pace of our scale-up readiness. And that's the period of time that we're in at the moment. I mean, there's risk with all battery technologies, but in this case, we're taking the steps towards being successful. So by designing a cell that meets and sits within existing regulation, we can move much faster. Looking at the lithium sulfur, and I've done it in this form, it's got some of the same points as we had up higher in the presentation, but I hope people can see in this representation some of the momentum that we're gathering. And we don't intend to slow down. Now, it doesn't look like a share price graph. Our share price graph, as a shareholder, I recognize the pain that it has declined in the last year. And I've been CEO in that period of time. What I am very confident in representing to the shareholders is there's been a lot of value that's been achieved in that period of time. And so where you get a difference between price and value, that does mean opportunity. And I do believe that we are developing a significant opportunity inside Gelion. We don't intend to slow down. We intend to continue this momentum, and we will be working very hard on all aspects of our business, the technology, on the match to market, on the work to prepare for commercialization and to put those relationships in place as we go forward into 2024, which I see being a very, very strong year for Gelion. Thank you. I think we can pass back now.
Fantastic. Thank you indeed, John. Thank you to the rest of the team for today's presentation. Ladies and gentlemen, please do continue to submit your questions just using the Q&A tab situated on the right-hand corner of the screen. Just while the team take a few moments to review those questions submitted today, I'd like to remind you that a recording of the presentation, along with a copy of the slides and the published Q&A, can be accessed via your investor dashboard. John and team, as you can see, we've had a number of questions, both pre-submitted and throughout today's presentations. So if I could just hand over to you, John, just where appropriate to do so, read the question, give your response, and we'll pick up from you at the end.
Okay, thank you very much. Look, the first one is, when will you get the share price back to £1.45? My answer to that is as soon as we possibly can, and I'm looking forward to it. We just completed a raise, and I will say that 10% of that was contributed by your board members. All board members participated, and it was led by our founder, Thomas Maschmeyer, who contributed, our chairman, your CEO, your CFO, and both of the non-executive directors. Everybody contributed to that round. So I guess we're stakeholders alongside the shareholders. And I understand that some of the earlier shareholders have still got a gap to be made up to, but I certainly hope that what we can do is restore that value for those initial shareholders and make new value for those that are coming in more recently. The second question is the company selling many of the batteries produced at the Sydney plant, and are they marketing them to solar installers for domestic household battery systems? And how much does each battery system cost? No, we are not selling the cells at the moment. The Gen 4 cells informed us in our R&D and our development work for Gen 5. They're not products that we have been commercializing yet. The next question says, does the zinc flow battery, when will it be available for domestic use in Australia? There is a need for personal storage of excess PV to be released to the grid in peak demand times, which will reduce the need for building of grid batteries and transmission lines. It would also help to stop the formation of new powerful electricity cartels. Our cells are actually, on the zinc side, a prismatic cell, and on the lithium sulfur side, pouch cells. So they are not flow battery cells, but I certainly appreciate the sentiment towards the need for masses of energy storage. That is indeed a primary reason that I am involved with GELION, because I do see both of our technologies, zinc and sulfur, as being technologies that can make a major contribution to the massive scale of energy storage needed around the world today. So we'll get on with that one as fast as we can. I've been trying to find out about next question. I've been trying to find out what the results were from the Acciona solar trial in Spain, and how did the batteries perform. It's promising to hear the new developments, but is there a reason why the Endure battery is not being produced and sold, especially in the light of new solar projects seemingly coming online on a weekly basis? Okay, so first of all, the Acciona project. We transferred the Acciona project from a physical project to a remote project. We're working very closely with Acciona. They are very good partners. I think the world of that company. Amazing organization. So actually in Sydney, we have a facility where the Gen 4 cells are being used today, and they're running through a test plan. That test plan was provided by Acciona, and the results from that test plan are visible to Acciona. There is a second stage to that, where we intend to set that facility that we have up, where Acciona can see the performance of the cells, and to connect them to a operating energy plan. We've discussed with Acciona at every stage as we've progressed, and they're very aware of what we're doing with the transition to our Gen 5 technology. We are in the course of adjusting the timing of our program and the relationships and everything that goes with it towards that Gen 5, and Acciona has indicated to us that they will accommodate our shift to the Gen 5 product, and look forward to testing it. So the outcome, again, very proud of the GELION team. They do a remarkable job. There's so many people that have been involved in achieving this, and so if any of them are listening, and I guess probably some of them are, thank you very much again for doing it. They've delivered pure quality through the course of that work, and so the facility that we're set up will be capable of being utilized as we bring on the new cell generations. And the BMS work and all the other pieces of the technology will put us in great stead to be bringing through our new technologies. Next question, could you please give an update on the Endure battery test? Well, I'm sorry, I just gave that one. It's repeated the question about Acciona, so I hope my original answer might be sufficient for that one. Next question, as the Iron Blocks collaboration has initial focus on the transport market, what is GELION's current grid storage technology, if any? That's a great question. Well, we see our battery technologies being used in grid technologies and being used in the transportation. We do see obviously the lithium sulfur being a high energy density technology is great for transport. We see the zinc technology as being a really important extension of the lead acid, and you might have heard me carefully use the word there, extension. We see that our zinc technologies can perform in certain areas where the ecosystem that surrounds lead acid can use it to great purpose. And that's what we want to do. We want to actually work with inside that ecosystem, and we'll be targeting applications such as remote power systems. Stuart mentioned earlier our objectives of being able to have a high temperature battery. And if we can achieve our goals with that and have a battery that can be used in a robust way in harsh conditions, that's going to be a great gift to the energy storage program and lead to a lot of sales because that removal of the air conditioning is a very important goal. The next question is, will it be possible for third parties to license the technology? The answer to that, yes, but only on strongly valuable commercial basis for our shareholders. So we do see that licensing can be an important source of reward to our company, but obviously licensing would be on an appropriate basis. The next question is, with the agreement with Iron Blocks, could you please discuss the IP ownership and commercial rights of the parties? That is actually set out in the RNS that we put with the announcement. But basically, both parties look after their pre-existing IP and all improvements on their pre-existing IP. Iron Blocks obviously is bringing primarily the skills on their anode technology. We're bringing primarily the skills on our sulfur technology, and to the extent we're both bringing certain skills on the electrolyte. Where there is new IP that's developed that is not built on the pre-existing IP of the parties, then that will be commercialized on mutual agreement between the parties. And then the commercialization itself will also be by mutual agreement. Next question is... sorry, just give me a moment to get to the next one. I'm seeing what would the predicted cost of the lithium sulfur battery be compared to sodium ion? Wow, that is a thoughtful question. That's a really good one. It's a hard one. Sodium ion is a low-cost technology and has a lot of promise. On the other hand, if you look at a lithium cell, I think 2/3 to 3/4, and I probably should be able to be more accurate on this question. I apologize to it, but I think it's between 2/3 and 3/4 of the price is the cathode over the anode. Now that's changing a little as people make more sophisticated anodes, but when we put sulfur into the cathode, we dramatically reduce the cost of the cathode. So putting it out there, I guess lithium ion is trying to get to somewhere around 110, like to get down to 100. Sodium ion is trying to, this is in dollars per kilowatt hour. Sodium ion is trying to get down to that sort of 50 to 80 range, and I would have thought lithium sulfur is going to be somewhere in the same range. So I think we can be competitive, but they're both great technologies. Next question, will the institutional investors start buying Gelion shares, so increasing shareholder value? I have to say thank you to a number of institutions who bought shares as part of our recent raise. And I will say that I do understand that the institutions that were part of the early financing of, or the early funding of Gelion have stuck in all the way through. So the institutions are very aware of Gelion, have been very loyal to Gelion, and we're very grateful for the institutional support that we have. And we want to be building support both on the institutional side and on the retail side. Next question. I am new to Gelion. I can see that Gelion has been involved in a lot of research. What products has Gelion already been and is currently manufacturing and selling? So obviously we're still in the development stage of our products, still developing it at the moment. So the revenue that you see on our books has primarily been associated with the research programs inside of the company rather than product sales. I've got a question here. With the acquisition of Oxlade and the signed JDA with Iron Blocks, when do Gelion expect to be cash positive? Now that's a really good question to be posing, and I'm going to give it to you that, you know, if I'm talking just in a pure organic sense, if I'm saying here just, if Gelion were just to take the two technologies forward and just do the research on the technologies and follow an ordinary course to commercialization, you're going to be looking at least, I think we have to say at least 3 years on that course, if not longer. However, as I demonstrated or showed earlier in this presentation, there's a lot of momentum in this company and there's a lot of commercial activity in what we're doing. I believe we've been developing a lot of value, and I intend to keep that process, or the board and I and everybody involved want to keep developing progress and momentum on value inside of Gelion. So there's a few strategic things in that. I think that we're going to keep improving that value, and that that's going to have an impact on the performance of the company as we go forward. So leave that one with me, and we'll be updating people progressively as we go. There are research reports out, and I can point people to Cavendish research paper that's actually on the website. Does the fact the iron blocks anode has no graphite get rid of the electrolyte compatibility issues? Does it have any benefits for the PSS issue? Well, actually, one of the good things about the work that we've been doing is that we've actually managed to develop electrolytes that seem to be supportive of graphitic approaches, as well as silicon approaches, as well as lithium metal. So good news there. As Thomas said, we have flexibility. Next question. With 7 million cash and revenues expected to be early as 2026, how would you sustain the business in the interim given the current burn rate? Will you be looking to raise more funds in 2024? Yes, in terms of we have positioned the company very strongly in the strategic landscape. So I've got to answer this question very carefully for you. I think at the moment there is possibly a discontinuity between the value of our company and where we are in share price terms. So do we want to be raising more money where we are? The answer to that would be no, we don't. We want to chart a course where we can increase value in the company and increase the value perception of the company. Will we need to raise more money before we get to the end of our journey and get cash flow positive? I would anticipate that is the case. Now, I guess if you read between the lines, what I'm saying is that if we get to that point, I'd like to be doing it on much better terms, and getting it on much better terms would entail getting proper recognition for the value that I believe is developing in your company, in our company, GELION, and moving it forward in that way. So one of our goals that we have set, we believe that we've developed the value inside GELION. We believe that we're developing leadership in some of our market segments. One of the greatest signals that we think could be sent to our shareholders if we can get external parties to recognize that as well. And that's one of our strategic goals going forward. So I am answering the question as completely as I can for you. And I hope that that is satisfactory.
John, I was going to say, every time you answer a question, we get another one come through. So we have gone just through the hour. So we can cover off all the questions. Any further questions do come through from investors post the meeting. But thank you for answering so many as we've come along. Perhaps, John, just before redirecting investors to give you their feedback, which I know is important to you and the team, we could just ask you for a few closing comments.
Oh, look, thank you for the opportunity to present. It's been a real honor to be the CEO of GELION throughout the last 12 months. I think we have a wonderful company. I wish I could throw a GoPro on my head and walk you through a typical day that we have in GELION, to take you into some of the meetings, to meet some of the wonderful team members that we have. Next week, we've got a purely wonderful week. We've got the guys from Oxford coming down for the first time to join us in Sydney. We've got a program of work going. We're going to be calling in with Sujit and his team over in San Francisco to advance the work that we're going on there. So if you're a shareholder, we're looking after your investment. If you're a prospective shareholder, love to have you along. Thanks for the honor of being the CEO of your and our company. Thank you.
Fantastic, John. Thank you and the team for updating investors today. Can I please ask investors not to close the session? You'll be automatically redirected to provide your feedback in order the team can better understand your views and expectations. This will only take a few moments to complete, and I know it's greatly valued by the company. On behalf of the management team, GELION PLC would like to thank you for attending today's presentation, and good morning to you all.